Welcome to this class on force, and we'll be looking at this very interesting physics topic. And I'm going to make the concepts really easy and clear for you. So I'm sure after watching this video, you'll find force super easy. And guys, do check out our website, manochaacademy.com. We have courses on physics, chemistry, and I'm excited to let you know that we'll also be launching the maths courses. So guys, do check out our website. We have got big discounts going on right now, and these will help with your preparation. And which reminds me, please apply your force on the like button and also apply your force on our subscribe button so that you don't miss out on any videos that we upload or the live classes that we have. So guys, do hit the like button right now and also share it out with your friends. So welcome to this class on force, and let's begin. So if you look at these pictures, I want to ask you, what causes motion? Can you see in this picture, the horse and cart, they are moving, right? So they are in motion. And this ball which is being played, so there's a game of soccer, football going on, and the ball is in motion. Okay, and here you can see the train is in motion, right? So the question is, what causes motion? Guys, can you tell me? Awesome, awesome, very good. That's the right answer. So we know in physics, right, we've been studying the motion chapter, and what causes motion? The answer is force, right? So here the horse is applying a force here, right? He's applying a force. And the soccer player, right, the footballer is applying a force on this ball, right? And the engine of the train is applying a force on the train, pulling the train. Excellent, guys. Super. So there's clearly a force involved here that causes motion. So which brings the next question, how do we define force? Or if I ask you, what is force? Right? So if you look at the pictures here, can we come up with a simple definition for what is force? Okay, so all of you try. So welcome everyone. Thanks for joining this class, and do hit the like button and please share it out with your friends. Excellent, super. So if you look at these pictures here, right? So I see a lot of you have the right answer. Can you see this person is pushing this stack of hay, right? So he's pushing this roll of hay. So we can say he's applying a push here, right? Can you see with his hands, he's applying a push, right? Does everybody see that? And similarly, if you look at this horse picture, right? This horse and cart is moving. So the horse is basically pulling the cart, right? So the horse is applying a, let me write that clearly. The horse is applying a pull on the cart, right? So excellent. The definition in physics for force is very simple. It's either a push or a pull, right? And we apply forces all the time in our everyday lives. So when you're pushing something, right? Let's say you're pushing your book. So you're applying a push, right? Or you're pulling a table. So you're applying a force, right? Which is defined as a push or a pull. Of course, you might find some more fancy definitions in your textbook. You can learn that as well. But this simple definition is enough, right? Force is defined as a push or a pull. Clear? Very good. Now guys, let me ask you, is force a scalar quantity or a vector quantity? What do you guys think? So I want everybody to try here, right? So I want folks, please write your answer. Doesn't matter if it's right or wrong. I want everybody to participate in the chat. I'm looking at your answers. So can you tell me, is force a scalar or a vector quantity? First, let's understand what do these terms mean, right? So scalar quantity means it has only magnitude, right? Or value. So it has only magnitude. Magnitude basically means value, right? And no direction. So that is the meaning of scalar quantity. And guys, what is the meaning of vector quantity? Okay, so I see some people are saying scalar, some are saying vector. So guys, what is the answer here? And vector quantity means something which has both magnitude and direction, right? So which has both a magnitude and a direction. So for example, if I say time, right? 20 seconds, it's a scalar quantity because 20 seconds is the value, but it has no Direction, I can't say 20 seconds north, right? 20 seconds south. That doesn't make sense, right? Similarly, mass, 5 kg, it has no direction, right? But what about vector quantities? Like we know velocity, right? 20 meters per second, and we can say a car is moving at 20 meters per second, let's say to the north. So it has both a value and a direction. So guys, what do you think it is about force? So definitely force has a value, right? Or a magnitude, because which we'll talk about, because this person is pushing this stack of hay with a force with a certain value. Similarly, the horse is pulling the cart with a certain value of force, right? Let's say the horse's force is stronger than the man's, right? Let's say it's double here or triple. So definitely it has a value. But now guys, think about it practically. When you're pushing something, does it have a direction? Think about it. So let's say you have a book on a table and you're pushing it, right? Then we can say you're pushing it on the north, towards the north, right? Or let's say you're pushing it towards the east or towards the west, right? So let's say this person is pushing the hay of stack. Let's call this, this is the west direction. So he's applying a direction, in this case is towards the west. So there's a force and it has a direction, right? And this, let's say the horse is pulling it towards the south. Just for simplicity, let's take the direction as south here, right? Okay. So let's say this cart is moving towards the south on the road. So very good guys, force is a vector quantity, because force, the answer is vector, because force both has a value and as we discussed, it has a direction. So when you apply a force, you can specify the direction. But sometimes in the question, you'll find the direction is not mentioned. That doesn't mean force doesn't have a direction. It has a direction, only we've not specified it. Okay guys, clear? Awesome. And now let's talk about so please remember that force is a vector quantity, magnitude and direction. Now let's talk about the types of forces. So we can broadly divide the forces into force at contact, right? So as you can see here, we have force at contact and force at a distance, right? So what do we mean by this here? So here, can you see that the person is pushing the hay, right? So when he's pushing this stack of hay, right, he's applying a force here with his hand, right? And there's a contact, right? So can you see this point of contact where his hand is, right? So there's a point, there's a contact between the hand and the hay, right? So this is called the contact force. Very good. Somebody has written science is life, right? Contact and non-contact forces, right? So this is we say it's a force at contact, or we also call it a contact force. Same thing, right? Because there's a actual contact. The hand is coming into contact with the object. Clear? Very good, right? Sharda Thakur says muscular force, right? So the type of force here is muscular, yes, but we are saying it's a contact force, right? So it's an example here. Very good. Now forces, can they also be at a distance? Can they be applied from a distance? Yes. One simple example is gravitational force, right? So guys, you know that the earth is pulling the moon, right? So all of you know this, right? The earth is pulling the moon, and is the earth in contact with the moon, right? So guys, is the earth in contact with the moon? No, right? So this gravitational force, right? So here we say this example is showing you gravitational force, which is an example of force at a distance, or we say non-contact force. Excellent guys. So you can also call it a non-contact force. Let me write it down here, right? So forces at distance can also be called non-contact force. Clear? Because the force, there's no real contact between the earth and the moon. It's applied at a distance. Similarly guys, when let's say this is the earth, right? So if this is the earth, and when a ball is falling towards the earth, so can you guys tell me, is this a contact force or a non-contact force? So come on guys, try this question. When a ball is falling towards down towards the earth, is it a contact force or a non-contact force? What do you guys think? Okay, so Shreya says non-contact, Uzair says non-contact, right? Yeah, because gravity, right? So gravity can act from a distance also. You don't have to be touching the earth, right? So very good. So here again, gravity is pulling the ball down, and it is an example of non-contact force. or we say force at a distance. Clear? You can use either of those terms. Excellent, guys. Very good. Okay. And there are some more examples of contact and non-contact forces. So whenever you see the force, always think about it, right? So I have a question here for you. So I'm going to play this video here and you tell me what type of force is this magnetic force. So please watch this video here. And guys, what do you think? This magnetic force, did you see that? Right? So did you see that the magnet is attracting that iron pin, right? It's attracting that pin towards it. So magnetic force, as you saw in the video here, is it a contact force or a non-contact force? What do you guys think? Superb. You guys rock. Excellent. Fantastic. That's the right answer. Magnetic force is an example of non-contact force, right? Because see, if you watch the thing carefully, right, you'll notice that, so if you watch it carefully, when it's attracting it, it's still at a distance. See, it won't touch the pin, right? See, it pulled it, the magnet pulled the pin without touching it. So clearly there's a non-contact force. So gravitational force, magnetic force. Does anybody know any other example of non-contact forces? Okay. Of course, when a magnet touches it also it can, but we don't say it is a contact force because it can also act from a distance. Okay. So very good, guys. Another example, if you'd like to know of a non-contact force, is electrostatic force. So remember the force between charged particles, or another example is force between the protons and the electrons in an atom, right? So protons are positively charged and electrons are negatively charged, and you know they attract each other, right? And so these are non-contact forces because the electrons are at a distance from the nucleus. Okay, so gravitational force, magnetic force, electrostatic force are good examples of non-contact or forces at a distance. Fantastic. Great, guys. Now let's go ahead and talk about effects of a force, right? So we know there are forces in our everyday lives. So what effect can it have, right? So guys, can you tell me what effect can it have? Okay, and I see a lot of you are here, but I see only a few likes. So guys, please hit the like button right now. Please give me a like for this class. I'd really appreciate it. And go ahead and take a look at this thing. Effects of force. What are the effects the force can have? Thank you, guys. Thanks. So it can set a stationary object into motion, right? So let's say this ball is stationary, right? So let's say we have a stationary ball here. It's not moving. So stationary means the ball is at rest. Okay. So let's say this ball is at rest and we apply a force on the ball, right? So we can set the ball into motion, right? As we discuss, force can cause motion. Okay. So that is one example of, we say it is an effect of the force, right? So that first point. Second is it can stop a moving object, right? So let's say the ball is moving. With your hand you can stop the ball, right? Okay, so you can stop a moving object, right? You know the players, whether you're playing cricket or football, right? With the hand or with their foot, they stop the ball, right? So stopping a ball, moving object, a force can do. So that's an effect of force, right? And change in speed of a moving body, right? So when a person hits the ball, right, or let's say you're playing tennis and with the racket you hit an already moving ball, you can increase its speed or you can decrease its speed depending on your shot, right? So you can change the speed of a moving object by applying a force, right, guys? And let's say this ball was moving. So if you look at the second ball here, let's say it was moving like this. Okay, so let's say the ball was moving like this. So this is the direction of motion. And you apply a force this way. So guys, can you tell me in this picture, what effect of force will happen here? Is it the first point, second, third, fourth, or fifth one? So guys, I'm talking about this picture. The second one, what effect are you going to see here? If the body is already moving this way and we apply a force upwards. So guys, what do you think here? Right? It's already a moving body. So it's not point number one, right? So out of these 4 points, can you tell me which one do you think is going to be the effect of force for this one? Okay, some of you are saying 4, 3, right? What do you guys think? Okay, Gautam says 4, very good. right? I see a lot of answers here. Srinivas is saying 4. What do you guys think? Goswami is saying 4, right? So if you take a look here, yeah, because what is the direction of the moving body? It was this way, right? So the body is already moving, and if we apply a force like this, can you imagine where the ball will go? Because it's already moving like this, so then I think the ball will have a path something this way, right? It's going to move because you've applied an upward force and it was already moving like this, so you can change the direction of the moving body. And yeah, some of you said 3, sure, the speed of the moving body can also change, so this could also be a possibility. But in this picture, you can clearly see the direction of the ball will change because an upward force acts, so it's going to change the direction of the ball. Okay, very good. So yes, it can be 3 and 4 also. And then you can change the dimensions, right? So let's say if you have a soft ball, you know that when you press it, you can change the dimensions of the ball, right? So let me ask you a question here, right? So I'm going to play this video for you, and you tell me what is the effect of force on the spring. So guys, take a look at this video carefully. Okay. So you can see I'm applying a force on the spring. And what do you think is the effect of force? Is it A, B, C, or D? What do you guys think? Come on, I want all of you to try here. You guys are being really interactive. It's awesome to see. I'll just replay that video again for you. So guys, take a look and tell me what do you think is the answer here. And I want all of you to try. It doesn't matter if it's right or wrong. We are all learning out here. So come on, guys. Awesome, awesome to see so many answers. Okay, so I see a lot of D's here. Okay, so if you look here carefully, right? So when you watch that video, what is the main thing you're seeing? That when I'm pressing it, can you see the, so let me replay it again, 1 second. So when I press the spring, right, you're seeing that I'm decreasing the length of the spring. I'm compressing it. And when I pull the spring, I'm elongating or increasing its length here, right? Can you see? So the primary effect as shown here is we are changing the dimensions of the body. Changing the dimensions means basically changing the shape. So in other words, we are saying when you change the dimensions, excellent guys. You guys rock. A lot of you have the right answer. Bingo, it's D. So you're changing the shape by stretching or compressing, by pulling, stretching the spring or compressing it, right? Very good. So please remember these different effects of force can be there, and sometimes force can cause multiple effects. Here you can, some of you are thinking the spring is moving, but that's right. Some parts of the spring are moving, but you can see the whole spring did not move, right? So the spring did not move to a different location. So there was no movement to a different location. So that's not the right answer, right? And we are not changing the speed here. So the spring is still on the table. We are simply changing its shape. Excellent, guys. Excellent. Right? So let's talk about another important concept. We are going over some really important concepts in force, and I'm going to make things crystal clear for you. So please listen carefully. And it's great to see a lot of folks out here. So let's talk about balanced versus unbalanced forces. Okay, so what do we mean by this, right? So if you look at the first picture here, right, can you see? So this is basically a box that I've shown here. So what you can see here is a box, right? So in all these pictures, this is our box here. And if you focus on the first picture here, a force is being applied, right, on the box. And you can see there's a single force being applied on the box, right? What do you expect here? So if the force is applied on the box, right, you can expect that the box will move, right? There's going to be some motion of the box. Can we expect that, right? So here we can expect that there's going to be some motion this way of the box, right? Okay, guys. And this is known as unbalanced force, okay? So this type of force is when you have one force acting like this and it's causing motion. It's called an unbalanced force. Okay, why do we say that? The force is unbalanced because there is a net force. So by unbalanced force, we mean there is a net force on the box which is not equal to 0, right? So there's an effective force on the box which is non-zero, and that causes, it can cause motion. And here, let's say the box is moving. Clear, guys? So the net force here is not 0, and these are called unbalanced forces. Now guys, if you look at the second picture here, again we have the same box, and now let's say we apply two forces which are equal and opposite. So one, as we said, it's a vector quantity, so this this force is applied towards the east direction and this one is towards the west direction. So guys, can you tell me what do you expect will happen here, right? Will the box move or not? Okay, and the forces are equal here. So come on guys, I want all of you to try. So do you expect, so before we answer balanced, unbalanced, do you expect this box to move? Okay, very good. I see a lot of you are giving answers here. Excellent. Not move, right? Excellent guys, correct. Because what will happen here, please look carefully, since the two forces are equal in magnitude, F and F, right? So it's not F and 2F, so both are equal in magnitude. So we have equal forces, so equal in magnitude but opposite in direction, right? They're opposite in direction, so you can expect they will cancel each other. And you can try this yourself. Take a book and try to push it with two fingers on both sides, right, or two hands, and with the equal force the book will not move, because in this case this is an example of balanced force, right? Why? Because the forces cancel each other. So these are balanced forces, and here the net force is equal to 0, right? So we can say the forces cancel each other. They're cancelling each other. And if the forces cancel each other, there's no chance of motion here, right? Because if the, very good, net force is 0, so the forces are cancelling each other. This is an example of balanced forces. Excellent. Clear guys? Very good. Okay, now I want you to look at the third picture here. So this was picture number 1, 2. Let's look at the third, and then we look at the fourth one. So in the third picture, can you see? Let's say this force is, let's denote it by F, and this is double the force here, 2F on the box, right? So we have two forces here. Now can you tell me, in the third picture, is it balanced or unbalanced? So please apply the concept. Is the net force 0 or non-zero? What do you think? And what is it? Okay, very good. I see Kirit Ghosh says it'll move. So guys, right, very good. I see a lot of answers here. Guys, what do you think? It's unbalanced or balanced? Come on, all of you try. Excellent, excellent. So this is a case of unbalanced force. Can you see that? Right? Here it is unbalanced. Why? Because what is the net force here? Let's take a look. So the net force is going to be, this is 2F minus F, right? Because it's in the opposite direction, so we'll have to subtract. So there's a net force of F here, right? And that's clearly unbalanced because it is not 0. So we have unbalanced forces here, and you can expect the box will move this way because the force towards the right or towards the east direction is greater than the west direction, right? So the box is going to move towards the east. So there will be motion this way. So please note, unbalanced forces can cause motion, right? So unbalanced forces can cause motion. Balanced forces, they do not cause motion, right? So they do not cause motion. Clear? Because the net force is 0. Obviously, if the net force is 0, how can you expect motion? Excellent, guys. And guys, what about the fourth picture? Come on, I want all of you to try. And here we have 4 forces here, so many forces, and they are all equal in magnitude, right? Okay, and the direction, you take a look yourself, and what do you guys think? Is it balanced or unbalanced? Come on. So for question 4, right? And yeah, somebody had written, I missed the name, I think Biju, right? He had written, it's another good example is tug of war. You know the game tug of war, right? So if the two teams are equally pulling each other, it's a case of balanced force. If they're pulling with exact equal forces, if the team are of equal strength, but the winning team is basically, if it's pulling with a larger force, then it's a case of unbalanced. Excellent example. So tug of war is a good example where when the forces are equal, then it's balanced. When forces are equal, it's balanced, right? And if one team is winning, then it's unbalanced. Clear? So very good, guys. Question number 4, the picture number 4 is balanced. Can you see? Because this force is going to cancel. So this force will cancel this force will cancel this force. And so the forces are cancelling each other. So this is again an example of balanced forces. The box is not going anywhere because the net force is 0. Clear? Crystal clear to you? Great, guys. And come on, guys, hit the like button and do share it out with your friends, because we want more people joining the Manocha Academy family. It's great to see the response from all of you and great to read the feedback. So let's continue on our topic, force. Now there's a very important formula in physics for force, F equal to ma. Yeah, and thanks guys for the likes. So please look at this very important formula. What does this formula mean? In words, if we say, you can remember it like this, that force, right? So force equals mass times acceleration. Okay, so that's what these words mean, right? So force, right? I wrote F there. Let me write force here clearly for you. So F stands for force. So force equals mass times acceleration, right? There's a derivation of this formula, but we won't go through that in today's class, right? We'll be taking a look. So you can derive this formula using Newton's second law, right? So you guys can explore about that. Yeah, it's based on Newton's second law. F equal to ma, one of the most important formulas in physics. So guys, please remember this one. M here is the mass, right? M is mass and A is acceleration, right? And F is force here. Okay, so let's understand what does this mean with an example. So let's say we have this box here, right? Can you see this box here? So let's say this box has a mass of 2 kg. Okay, and we are pushing it with a force. Okay, a force is applied on the box. It has a mass of 2 kg and the acceleration of the box is, so when we push it with a force, its velocity will increase, right? So we can say force causes acceleration, it causes motion, and the velocity is increasing. And let's say the acceleration of this box when we are pushing it is 3 meters per second square. So guys, can you use this formula and work out the force for me? I want all of you to try. Some of you are writing mass into gravity. Okay, so don't confuse. That's a special case when we are talking about weight. Okay, this is a general formula. So guys, please don't confuse this formula with F equal to mg. That's a special case of this formula. The general formula is force equals mass into acceleration. Super, all of you, a lot of you have already written the answer. So I can see Albert Einstein says 6 Newton, Raj says 6 Newton. Excellent guys, super. So if you just use the formula, very simple question, just use the formula F equals ma, right? So F equals mass, force is mass times acceleration. Simple, just substitute the values here. So what are the values? Mass is 2 kg, right? And the acceleration is 3 meters per second square, right guys? So if we multiply these numbers, we are going to get 6 kg meter per second square, right? So first multiply the numbers, 3 times 2 is 6, and then we'll also multiply the units. Okay, and very good. Jay Reddy says, so 6 kg meters per second square is basically, we don't have to write this whole thing, kg meters per second square. It's known as 6 Newton, right? After the famous scientist Sir Isaac Newton. So it's called 6 Newton here, right? So kg meter per second square is basically, remember that the abbreviation for this is Newton. So the SI unit of force is Newton. We don't have to write kg meter per second square, right? Excellent guys, excellent. So please remember Newton is the SI unit of force here, right? And so the force that we are applying on this box, so please clearly understand this. So whenever you're pushing something, right, or pulling something, you're applying a force, and that force causes an acceleration on the body. The body here is this box, right? So it's this box here. And please take a look. If the box is 2 kg, and if you give it an acceleration by applying a force of 3 meters per second square, by our calculation, by using this famous formula, it means force equals 6 Newton. Clear guys? So very simple formula that you can use to calculate the force. Okay, mass times acceleration. So come on guys, I want you to try this question now. What is the acceleration of a ball of mass 100 gram, right, if a force of 2 Newton is applied on it? So come on, I want all of you to try this question and let me know the answer. Okay, I see Isaac Newton's here also on the chat. So yes, it's we have Isaac Newton here as well in our session. And so Newton, yes, Newton is the SI unit. And please remember to write with a capital N, okay? And one very important tip guys, so this is written as 2 Newton here, you see, right guys? But when you write the full form, you have to write 2 Newton with a small n. Okay, please remember this. So when you're writing the abbreviation, capital N. Okay, and when you're writing this, it's a small n. Okay, great guys. So come on, I want all of you to try this question. Excellent. Please go ahead and see how will you solve this question here. So come on guys. So what is the question given here? The mass. So always, write down the data clearly. So let's take a look at our data given here. So the mass is given as 100 gram. That's the mass of this ball, right? 100 grams. So let's write it down very clearly. M equals 100 gram. Okay. And what is the force given to us? A force is applied of 2 Newton, right? So the force on this ball is 2 Newton. And we need to find the acceleration on this ball. What is the acceleration here, right guys? So that is the question. So what do you think is the answer here? Come on, all of you. So basically we need to apply our formula, right? F equals force equals mass times acceleration, ma, right? The famous physics formula, F equals ma, right? So what is acceleration? Acceleration is basically nothing but, since we want to calculate that, so we'll take that on the left hand side, is force divided by mass. Simple. You just need to rearrange that formula. Okay. So I see a lot of you are saying the answer is A. Okay, let's see, what do you get? So if you substitute the values here, let's see what do we get. Force we are going to substitute. So let's try it out. Force is 2 Newton here, right? 2 Newton. Okay. And what is the mass? Should I substitute 100 grams here, right? So this is where guys you need to be really careful, because remember Newton is the SI unit of force. So the mass also needs to be in SI units, guys. Be careful here. Very good. Some of you are saying no, don't put 100 grams because there'll be a problem of units, right? Remember, when you're doing sums, you need to stay in the same unit. Okay, so if you're given in different units, you should convert. So guys, please don't forget to convert this to the SI unit of mass. What is the SI unit of mass? Can everybody tell me here? Come on guys, what is the SI unit of mass? So first tell me, what is the SI unit? What unit should be converted to? Okay, I see a lot of you are giving the answer. Okay, great. I see Mondal has said kg, right? Vishwa, kg, very good. So that means we need to convert this to kg. So 100 gram is basically 100 by 1000 kg, right? Be careful. So that's basically 1 by 10 kg, or if you like 0.1 kg, right? So 1 by 10, I usually like to use fractions, right? So 1 by 10 kg. So please remember, don't substitute 100 grams. So this is going to work out to be 2 Newton divided by 1 by 10 kg. And now if you calculate, what is your acceleration going to turn out to be? So it's going to be 2 times 10, right? So 20 is the number. And we don't have to worry about the units. We know we are all in SI units. Newton is SI unit, kg is SI unit. So what is the SI unit of acceleration? Meter per second square. As you can see in the options also it's given. So very good guys. Those of you who said D, excellent. So guys, this is where they trick you with the units. Be careful about the units. Make sure you're in SI units. Okay. So here mass has to be converted to kg. And then you just apply our formula. Remember this very important formula. We just used it and we rearranged it to get acceleration is force by mass. So the correct answer is acceleration of this ball is going to turn out to be 20 meters per second square. Okay, clear? Very, very important, right? Units are very important. So let's talk about the units. So guys, what is the SI unit of force? What is the SI unit we learned today? So come on guys, can you tell me? And great to see all of you interacting and participating in this. I really love your response. Okay, again, I'll warn you, some of you are writing Newton with the capital N. Be very careful. If your science teacher is strict, you'll be given a wrong, right? So be careful when you write the SI unit of force. It should be written with small n, right? Of course, we have all respect for Sir Isaac Newton, but when writing the unit, not his name, we are writing unit, it should be written with a small n when you're writing the full. And the abbreviation is with the capital N. This is a very common mistake. Okay, guys. So very good. I see a lot of you are taking care in the chat to write with the small n. Please remember, don't start with the capital N. We are not writing the name of the scientist here. We are writing the unit. Okay guys, so Newton with a small n, and bracket you can put the abbreviation. Abbreviation is in capital N. Clear? And guys, do you know what is the CGS unit of force? So remember, the CGS stands for centimeter, gram, second, right? The SI, you know, we use meter, kg and seconds, right? In the SI system, what is used? Meter, kg and seconds, right? Okay, so guys, who can tell me? Very good. Sanjeev says dyne, right? Vishwa says dyne. Excellent, guys. Vinod says that. Superb, guys. Wow, very good. So you guys know your units well, and please remember to apply them when doing the sums, right? It's good to know the units and also remember to apply it. So what is the CGS unit of force? Please remember that it is dyne, right? So how do we, so let's understand that how would we define Newton or dyne? So let's talk about that. So first remember these names, right? And I don't think dyne has a short form of D or something. We have to write the full word. And again, guys, I'm seeing some of you writing dyne with a capital D. No, guys, when you write the unit, it's with a small d. I don't think I know any exception of a unit which the name of the unit starts with capital D. So please don't write dyne with a capital letter, right? It's with a small letter. Please take care of it, because these are, yeah, very good. Now I see in the chat you guys are writing with small d. Excellent. So how can we define 1 Newton? So who can tell me? So we talked about this unit is, we talked about force, right? Force is measured in Newton, and Newton is the SI unit. So how would you define 1 Newton? Okay, so yeah, I'm not asking how do we convert Newton to dyne. Right now the question is, basically we're asking what is 1 Newton of force? How do we define it? Okay, so I'm going to teach you a very easy way to remember this, right? You don't have to learn up any definition. The thing is, just use the formula that we learned, right? We learned today force. The force formula is mass times acceleration, right? MA, mass multiplied by the acceleration. Okay, so how do we define 1 Newton? You can just remember it very easily with this formula. So basically, if you take a mass, if let's say a body has a mass of 1 kg, and if we apply a force and we give it an acceleration of 1 meter per second square, right? So that's what we do to the body. So if you multiply these two numbers, 1 kg and 1 meters per second square, you're basically going to get, it's 1 into 1, right? So this is going to give you 1 kg meter per second square. And remember we said kg meter per second square is nothing but Newton. So that's basically 1 Newton. Okay guys, so how will you remember this, right? So some of you are saying no, not moving it by 1 kg, to give it an acceleration, because please remember the force is connected with mass and acceleration, nothing to do with displacement here, nothing to do with the velocity, right? We are talking because when we apply a force on a body, we give it motion and we there's an acceleration involved, right? When an unbalanced force is applied, not a balanced force, because balanced force is net force is 0, right? So when you apply this force, using this formula, you guys can remember F equal to ma. So 1 Newton is basically 1 kg times 1 meters per second square. So how do we define 1 Newton? The force, right? What is 1 Newton of force? The force when you force applied, sorry. So let's say 1 Newton force, the force applied on a body of mass 1 kg, right? And when we give it, so force applied on a body of mass 1 kg, and we give it a acceleration, give it an acceleration of 1 meters per second square. I'm just writing it in short. Then the force is 1 Newton. Then force is 1 Newton. Clear? Right? So the force is going to be 1 Newton. Clear, guys? So basically you can remember it with this formula. You don't have to learn up any definition. By the formula, you know, when you apply a force on a mass of 1 kg, giving it an acceleration of 1 meters per second square, that is 1 Newton of force. Okay, and of course it can be for 2 kg and half meter per second square, but we won't complicate the definition because 2 times half will also give you 1. So just remember it with this simple thing. Excellent, guys. Clear? Very good. And now some of you are already answering that question, right? 1 Newton, how do you convert that into dyne? So come on, who can tell me how do you convert? So again, we don't have to remember this, right? How do we convert the, so this you know is the SI unit, right? So here we are in the SI unit, and this you know is the CGS unit of force, right? So how do we convert 1 Newton to dyne? So let me show you a very simple way of how to remember this derivation, and then I think you won't forget it for the rest of your life, right? You'll always remember this. So please take a look. How do we do this? 1 Newton, as we said, is nothing but 1 kg meter per second square, right? Because we are in SI units, kg meter per second square, right guys? This is what is 1 Newton. And our goal is to convert it into dyne here, right guys? We want to convert it into dyne. Very good. Some of you already have the answer. Oh, I forgot to write. Yeah, we've written dyne, so we wanted the number here, right? So this really doesn't matter. It's basically the number. We are converting it into dyne. All of these are in dyne. Now let's say, so what is dyne here? So let's write that down. Dyne we know is nothing but gram centimeter per second square, right? Okay. So dyne is 1 gram. So 1 dyne is 1 gram centimeter per second square. And we want to convert 1 Newton to 1 dyne. So this is our goal, right? We want to convert from this unit to this unit. So let's start with what we've been given. So we know that 1 Newton is 1 kg meter per second square, right? All of you know this? Simple. And so let's convert. We want to convert it into gram centimeter per second square. So let's convert the kg into gram. So this is nothing but, so we can write this as 1 kg times 1 meter per second square, like we discussed, right? So 1 kg is nothing but 1000 grams. All of you agree? So 1 kg is 1000 grams, and 1 meter per second square, we want to convert it into centimeter per second square, right? So that's nothing but 1 meter, you know, is 100 centimeters, and second square, there's no need to convert because it's second is the unit in both SI and CGS system. So 1 meter per second square is nothing but 100 centimeters per second square. Now guys, what you need to do here, just collect all the numbers together. So what are all the numbers here? We have 1000 times 100 and then gram centimeter per second square, right guys? And so if you take a look here, what are we getting? So this is 5 zeros, right? 1, 2, 3, 4, 5 gram centimeter per second square, or if you like, you can write it as 10 to the power 5 gram centimeter per second square, right guys? So see, we just simply converted towards our goal. So we converted the SI system, the kg to grams, the meter to seconds. Excellent guys, a lot of you've got the right answer. The correct answer is 1 and 5 zeros. So you can remember 1 Newton is 1 lakh dyne or 100,000 dyne. Clear? And this is how you remember it. So if you ever forget it in the test, you can just do this 1 minute derivation and you can find it's very important to practice the unit conversions. And this is the key. The key step is here, converting kg to gram and meter to centimeter. The rest is simple, just multiplying. Superb. I see Ansh has got the right answer. Yuvraj, fantastic guys. Awesome, awesome. And great to hear a lot of you enjoying the session. Thanks a lot. So please do share it with your friends. And let's try this question. Do you know what instrument can be used to measure force? So come on, apply your practical knowledge or what you've learned in your classes 7, 8 or earlier classes, right? Or what you're learning right now. So what instrument can be used to measure force? So come on, who can tell me? Is it a beam balance, a spring balance, a speedometer or an odometer? And come on, can I get a like from all of you? So guys, do hit the like button and go ahead and try this question. And I want answers from all of you. Very good. I'm seeing some people are saying A, B, okay, C, D, a lot of answers here. So guys, what do you think it's going to be? And thanks guys for the likes. Oh, great. We've reached 200 likes. Come on, I'd like some more. Excellent, excellent. So how will you remember this one? Let's go option by option. Let's start from D, right? The last option. So guys, you read about this in the motion chapter. Odometer in a car, right? Or in a vehicle is used to measure the distance traveled. Okay. So this is definitely not the way to measure force, because we want to directly measure force, not calculate distance and speed, you know, and then do some calculations. We want to measure force. So D can't be an answer. And guys, you know, speedometer, right? So speedometer is used to measure speed. You guys know that, right? The speedometer of a vehicle is used to measure speed. Okay. So that is certainly not the correct answer here, right? Because we are looking to measure force. Our question is saying which instrument can measure force. Now, is it beam balance or spring balance? Okay, very important concept in physics. So beam balance, guys, is used to measure mass, right? You know, the beam balance, right? When they put the object on one side and the weights on the other side, you're basically measuring the mass of the body, okay? And you know that mass is not force, okay? And guys, you can remember this, that if you guys know, spring balance is used to measure weight, okay? So, and now my question to you is weight a force? What do you guys think? Is weight a force? Okay, we didn't talk a lot about weight today, but think about it. What is weight? So if you take any body, right? So if you take any body like this, right? The weight is basically, so what is weight here? Right? So we are talking about, okay, I used yellow for weight, so let me just redraw that quickly for you guys, right? So let's draw the body in orange here. So let's say we have this box, right, which is our body, and the weight is the force due to gravity which acts downwards, right? You know the weight of the body, and a lot of you are saying, yes, the weight has the formula mg. It's a special formula where g is the acceleration due to gravity. So you guys can look about the research on this on your own. We will not go into details in this class. So weight is also a force, just like force is m times a, right? Because weight is the force with which the earth pulls a body towards its center, right? So weight is the force due to the earth on the body, right? Force of earth, right, on a body. And you know that it is, the earth is always pulling a body to the center, right? I'm sitting on the chair here because of the force of gravity, right? Otherwise I'll be floating around in the room, and so would you, right? So you know your weight is pulling you down. And you might know this, that when you're traveling, you want to measure the weight of your luggage, you use a spring balance to measure the weight of the luggage, right? So weight is a force, and so the correct answer is spring balance. And you can also, let's say you use a spring balance to pull a table. So you can use the reading of the spring balance to measure the force that you've applied on the table. So typically spring balance, yes, it's used to measure weight, but whenever you're pulling something, if you pull it along with the spring balance, right? So use the spring balance to pull it, the reading of the spring balance will give you the value of force. So very good, guys. Those of you who said B, if you got it wrong, no worries. You've learned the concept. So guys, the correct answer here is spring balance. Excellent, excellent. And here's one homework question for you, which I want all of you to try. Interesting question. A man is pushing a heavy box as shown in this picture. The box does not move. Okay. So this is the box here, right? Can you see the heavy box that he's pushing? It does not move. What is balancing the force of the man, right? Because it's not moving, it's clearly a balanced force, right? So is it gravity? Is it friction, the weight of the box, or normal reaction? What do you guys think? I won't give you the answer here because I want each one of you to try it. And guys, do write your answer in the comments below. I promise to take a look at your answers and I'll try to reply to them as soon as possible. So guys, please write down your answer in the comments below. I look forward to reading everybody's answers, okay? Excellent, guys. So here are your things, and you can also try this practically yourself, right? Take a heavy box or something heavy, try pushing it and think, because physics is all about the physical world, right? So you should try to connect your everyday life with science, right? That's the goal. And so you try it yourself and think about it, analyze, is it due to gravity, friction, weight of the box, or normal reaction? And I look forward to reading everybody's answers. And guys, as I mentioned, we have this website. It's actually a web app, you know, because you can use our website, our web app on a phone, on a tablet, or on your desktop computer. So that's the nice thing. You can use it wherever you want. So it's not just a website, it's a web app, manochaacademy.com, and we have these courses on physics, chemistry, and soon we are going to be launching the maths course for class 10 this week and for class 9 next week. So guys, do stay tuned and do check out our courses. I'll put the links below, and please do share it out with your friends. Thank you guys for your support. I see a lot of awesome comments here on the chat, and a big thanks from Manoj Academy team because we keep reading your comments, and it's great to see all the lovely feedback from each one of you. So thanks a lot for your support. Guys, do try the question I gave you and do check out our website. And if you haven't subscribed to our YouTube channel, please hit the subscribe button right now. Click on the notification bell so that you don't miss out the live classes. and the videos that we upload. And guys, do hit the like button and please share it out with your friends. Okay, so do let your friends know by WhatsApp, Facebook, send it out to them so that we can have more people on the classes. And thanks a lot. This is Sandeep Manocha signing off. It was a great session. You guys really participated well, and I hope the concept of force is crystal clear to you. So please apply a force on the like button and a force on our subscribe button. Thanks guys for being here, and please stay healthy, stay safe. I pray for everybody's health, and it was a great session. Hope you enjoyed it too. I loved it. Okay guys, take care. Bye.